The last thing that we want to talk about as sets is there are certain common sets that mean common things. And so I'm going to write those out here. The first common set that we are going to see is the set Z. And Z is actually the set of all integers. If I want to indicate a set that contains all integers, whole numbers, positive and negative, I'm going to use Z. If I want to do only positive integers, I'm going to use a Z plus. When I'm using the ellipses or the three dots, I need to indicate a large enough pattern so that people will know how to continue where the ellipses are present. The next set is called natural numbers. These are all natural numbers. For the purposes of our book, a natural number is just a Z plus that contains the number 0, 1, 2, 3, 4, 5, and so on and so forth. There is another common set, which is Q, and Q is all rational numbers. Rational numbers are numbers that can be represented as fractions, such as 1/2 and 2/3 and 5/16. I'm not saying that they are fractional numbers. They are just numbers that can be represented as fractional numbers. And then we have real numbers. So real numbers are fractional numbers and non-terminating decimal numbers like 3.3333, non-terminating decimal numbers. I did want to sneak in here and mention that real numbers also include all rational, but also irrational numbers. Irrational numbers include things like the square root of 2, the square root of a -6. So there is a JPEG that kind of helps visualize all of these numbers. So all integers are positive and negative, whole numbers are 0 and all positive, and natural numbers are just 1 and above whole numbers. You can see that all real numbers include both rational and irrational numbers. So I did want to mention to you a difference between what we are seeing in our textbook and what we're seeing in the Xi book. So our textbook says that n includes 0 and Z plus does not. The Xi book and the diagram that I showed you and Wolfram Math say that Z plus and n are equivalent values, that they are positive n's that do not include 0. Again, whenever you see a discrepancy between the Xi book and the textbook, we're just going to go ahead with our textbook, not because it's right, but because that's the reference material that we have for the quizzes and exams. So the way that we might use one of these sets is I might say something like A is equal to Z, and B is equal to Z plus, and C is equal to A, which is equal to B, which is all equal to N. So this is a way that I could use these common set notations in order to describe some set A or some set B. For the purposes of this class, we're going to concern ourselves with Z and Z plus for the most part, and perhaps N. We will get into fractional numbers a little bit, but we will not get into irrational numbers. So then the last thing that we're going to talk about as sets is a special set called the null set, also known as the empty set. As you can imagine, the empty set is just going to be an empty set of curly braces. If I call it the null set, I can represent it as a 0 with a line through it. So what do you think is the cardinality of the empty set? Well, because it's empty, it wouldn't have anything in it, right? And so the null set, the cardinality of the null set would be exactly the same. It has nothing in it, obviously, given the name. Therefore, its cardinality would be 0. When we start talking about subsets, we're going to come back to the concept of the null set or the empty set and how it relates to subsets, which, by the way, is the next topic. So hopefully this is all making sense. Let me know if you have any questions.